if any of you have feet like that, I would like to see them and take a picture. But, all right, so let's talk about animals and some of the things that we see. If evolution, which is a random process, should there be any similar design characteristics in anything? If everything's, I mean, think of the big bag of Legos. Shake, 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 throw it out. Okay, that's nice. Put them in the bag, shake, 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 put them out. Should we see anything similar? Not necessarily. Nope, that's very doubtful. But intelligent design by God, now let me just stress something here before I forget. It's not bad to say intelligent design. Okay? It's not. But I always say, if you're going to use it, tell them who the designer was. It's intelligent design by God. Don't leave that part off. All right. So, wouldn't you expect some similarities? I mean, dogs and horses and four-footed animals have similar type legs and structures and muscles and those characteristics. So let's look. Is there any evidence that there are similar characteristics? When you study science, you have to study a little math. So the Fibonacci pattern in creation. And the Fibonacci pattern is this. Let me just, okay. It's, each number is the sum of the two preceding numbers. That's known as the Fibonacci series. I put it up here for you. So it starts 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. Okay, we can go up as far as you want to go. You just add the two previous numbers together. All right? Does that make sense? Okay. The ratio of successive pairs is the so-called golden section, which is 1 point, and I'm just going to round this off, 1.6. All right? So you have the first one. So in our first sequence, let's say 2 and 3. First one is 1. The second one is 1.6, bigger. And each one progressively gets bigger. So remember that ratio. When we put a golden rectangle where one side is 1, the vertical here is 1, the horizontal across here is 1.6. This is called the golden rectangle, and it's used in, and I'll show you a picture of where it's used a lot. It's used in architecture a lot. But it's used based on the Fibonacci series. It starts at the middle of that little spiral there, and if we connect the diagonals of those, each one of those squares that fit in there, rectangles that fit in there, we get this nice spiral shape, all right, which fits the Fibonacci pattern. So, they use it in architecture. That's the same exact square fit over, okay, the Parthenon. And it's used because it is pleasing to our eye. It just fits naturally, okay? But we see it in nature. The golden ratio shows up, yeah, I have to always stop and look at this one. The golden ratio between the dots on the wings fits into the Fibonacci pattern. Now, it's a little hard to see, but that's getting you started, okay? It's there. If you look at a tree, it fits the Fibonacci pattern. The trunk is 1, then the next one up is, it divides, you have 2, then you have 3, then you have 5, then you have 8, and then you have 13. I challenge you to go out and look at a tree. Now, not all of them, I'll guarantee that, but I sit in my house and I'm going, oh, yep, that one does. Oh, yep, that one does. Oh, yep, that one does. But it follows the Fibonacci pattern. Want to know something more interesting? Your arm fits the Fibonacci pattern. Your hand is 1, and this from the wrist to your elbow is 1.6. Oh, that was just luck, right? Just random. All the bones in your hand are 1 to 1.6. No matter what 3 bones you look at, it all, even the small ones, it's 1 to 1.6. Pretty amazing for random chance, right? All right, let me go on. Our faces fit the Fibonacci pattern, the golden rectangle. In fact, the closer we are to 1.6 in the ratios between our eyes, our ears, our nose, where everything's placed, is the closer to 1.6 we are, the more beautiful we are considered. So you look at, you know, some of these models that are up there, they're all fixed up and all this. Okay. You put that pattern on there, it fits. Yeah, random chances are just amazing, isn't it? Okay. You go, okay, that's, yeah, we got a few things. All the flowers. 1, 2, 3. Oh, that was just lucky. No. 5, 8, 13. Starting to get the picture here. 21, 20, or 34. Those are all different plants. They follow the Fibonacci patterns, the numbers. Now, somebody will say, but there are 4 side. Yes, there are. My God has diversity, and he threw some extra things in there for us. All right? He didn't want us to get bored, so he threw something and said, let me see how they explain this one, okay? So, you think there's any other spirals that you see? How about these? The filiary, the stork bill, fiddleheads, that God used designs. This one down here, the filiary, those are so neat because those pop off the plant. They land in the dirt with the point down, and when it rains, do you know what it does? It screws that seed in. And it makes one of those every time. Roses are in spirals. This broccoli is in, I don't know if I'd even eat this, but I mean, you know, it's, it looks kind of neat, right? It's all in, spirals. Spirogyra is an algae. All its internal organisms and structures are in spirals. The agave cactus is in a spiral. How about some more? The sunflower head, and you can go from left to right or right to left, center in, center out. I don't care. They're all in spirals, and they all fit, and you don't get lost. The cone scales along the outside of a pine cone are in spirals. Next time you have a strawberry, look at the seeds on the outside. They're all in spirals. All over. So you go, oh, well, there's some plants, you know, that's it. How about these guys? Moth. Their tongues curl up. I mean, think about it. If you had a tongue that long, you'd want it out of the way too, right? If you're flying around and you get caught on something, it'd be like, oh, wait, oh. So he curls it up into a nice, tight spiral. Bumblebees, or all kinds of bees, follow the Fibonacci pattern between the head, the thorax, and the abdomen, 1 to 1.6. In fact, honeybees follow the Fibonacci patterns in other ways. In the hive, there's always 1.6 females to males. All right? And their family tree goes the same way. It's in the Fibonacci pattern. So here's a nice up close. And oh, here's a little secret. from an aerodynamic standpoint, bees can't fly. But don't tell them. They think they can. Okay? I'm just telling you, aerodynamically, they shouldn't be able to fly. But nobody told the bees, so that's good. How about chameleons? They wrap their tails up. And you go, wait a minute, those are all dyed or something. No, those are their actual colors that they can change just like that. You can go on YouTube and watch them. They'll put a pair of purple sunglasses and they crawl over them and they turn purple, and then they put a white one down and they turn white, and then they get a black one and they put black, and then they put 3 or 4 of them and it turns out multicolors. So he changes instantly. How about these? This is a pangolin, which is a small anteater, but he curls up into a spiral and lets, when he's in danger, and God gave him a hard shell, armor around his outside, he just waits till it's time everything's gone. Conch shells, a garden snail, all have spirals. How about big animals? Any big animals have? How about these guys? Bighorn sheep, the kudu antelope in Africa, nice spiral shapes. How about the Nubian ibex? That's over here on the left. The warthog and the markhor. They're from Pakistan. That's a tight spiral. How about a millipede? They roll up. And this is a goat with spiral horns. Occasionally you get some with spiral horns. Now, think about all the things that we talked about. Flowers, galaxies, which we'll talk about Wednesday night, are in spirals. Even our DNA molecules deep within our cells are all spirals. And let me tell you something. You think they follow the Fibonacci pattern? Yeah, exactly, perfectly. 1 to 1.6. Okay, so let's look at some other evidence. So now we see there are patterns in creation. God designed things. He said, I like spirals. And he made a bunch of stuff. Let's get a little more complicated. What color is this lovely butterfly? Take your time. No? Really, I don't want to rush you into any kind of answer. Huh? Red. Yeah. You're the same one. You should go to the principal's office. All right. So scientists looked at that and said, boy, some scientist someplace said, wow, I bet my wife would like that color. I'll find out what kind of pigment is in there. And so what they did was we did some experiments on it. We finally put a little water on there. Wait a minute, they changed colors. Wait, that doesn't make sense. So they said, let's look a little closer. So they looked at the flaps on the wings. Those are the feathers on its wings, if you want to consider it that way. But look at, they're still blue. So we took an X-ray, of course. We have bigger machines to go to. That doesn't tell us anything. Took it sideways, that still doesn't tell us anything. Till we got down to the microscopic, smallest we could get. And this is on the outside of every flap on every feather on his wing. I call them Christmas trees, for lack of a better word. What that does is, when light from the sun comes in, or any kind of light, it has multiple colors in it, right? Okay, multiple colors come in. Those are at the precise angle that fluorescent blue is reflected back. So that butterfly is black. It has no color in it whatsoever. And when you look at it, when this little butterfly, I chased one around a butterfly house, didn't I? I chased this butterfly around trying to get this picture, and he's flapping around doing all this kind of stuff. And as soon as he lands, you know what he does? All butterflies do this, I found out later. They fold their wings up flat. You know what's on the opposite side? Camouflage. You can hardly see him. But he's black. Now, how did a butterfly one day go, I better grow some Christmas trees on my wings so that I can be fluorescent blue? I don't think that's what had happened. God designed him that way. Let's look at another one. Anybody know what this is? Other than a bug? I'm waiting for this smart aleck kid to say the bug. What is it? Anybody? It's a bombardier beetle. All right. Whoops, let me back up. They're about this long. We find them in South America. Okay, these are very, very interesting bugs. You see this is called a bombardier beetle. These are interesting because they are fire-breathing, except it comes out the back end. But it's it squirts. It's a toxic chemical that explodes as soon as it releases. Now, I got a little clip from Job Martin, and we'll see if this might be on there. We're going to check to make sure the sound's okay. Maybe not. Yeah, that's okay. It's not going to work. Okay. I'll explain it. He has two little fire chambers in his back at the base. Okay, oh, there he goes. Okay, there he goes. I think it just had to load. But you can't hear it.
Make the sound.
No, my sound's up.
No, you make the sound.
I'll make the sound. Okay, it's two little fire chambers. He injects his chemicals that mix together. He puts in a catalyst, because if he didn't have the catalyst in there, it would blow him up. So it waits, it expels it, and it blows it out. Now these two little turrets can hit anything. See, he's pinching the middle leg. He aims, and he fires. All right? He aims and fires. Now here's a spider. Comes up alongside of him before he could get away. Now watch. You'll see a little puff. There. He shot the spider. And he went away. Job Martin is a creationist that I know. He used to be a presidential dentist. But what he found out, he doesn't one big blast, because if it was one big blast, he'd go this way, the opposite way, just like a jet engine. So what he does is he squirts 1,000 little squirts. So he can stand right there, shoots them, and he can repeat it over and over and over. It doesn't matter. And it just fires. So it just keeps going. And he never misses. That's what's cool. Now, I have to tell you a story. We were in Nebraska, Natural History Museum, and they had a display of Charles Darwin. And Darwin was a bug collector. So he was down in South America, and he goes, ooh, I don't have one of those. So bug collectors are kind of weird. They pick it up. He's holding it in his hand, this bug. And then he goes, ooh. He didn't know what it was. It was a bombardier beetle. Picked it up in this hand, okay? And he goes, ooh, I don't have one of those. You know what he did next? Took the bombardier beetle, put it in his mouth. And just, I said, oh, God does have a sense of humor. Oh, that's, I think that's wonderful. So, all right, that's it. Okay. So, bombardier beetles. Could there be fire-breathing dragons? Sure, why not? They do the exact same thing. Remember I said there was two tubes came down? That's all he's got. A little couple of glands in there, and you got your fire breathing right away. How about, there we go. How about woodpeckers? Yeah, we'll get to some interesting animals that you see. Not only do these birds fly very well, but they have some unique design features. His tail feathers act as a third leg. I don't know if you've ever seen that, but watch a woodpecker. He puts his tail down. Most birds don't. put his tail down, and acts as a third leg, so he's got a triangle. He's very stable, no matter which way he faces. He has special feet. Most birds have just 3 toes, 2 in the front, 1 in the back. So if you look at them, a woodpecker has 2 in the front and 2 in the back. And that is because he needs those. If he's on the tree this way, sideways, he'd fall off. But he has 2 and 2, and it clamps him on there. Now, what does a woodpecker do? Well, he pecks wood, doesn't he? He gets on the tree and he drills holes, or the side of your house, or whatever it is. But he drills holes looking for bugs. So he has a very thick, tough beak. Can you imagine if you spent all day, you're pounding your head against, a hard tree? I would come home and go, I have got the worst headache. Okay, he doesn't. When he comes home, he's got a special cartilage between his brain, okay, and his skull, so that when he's doing his job, okay, it's bouncing on it and softening the blow. They're looking at him for football helmets, and those kind of things now. Okay? So, when he's drilling, and you've heard woodpeckers, right? It's not tap, tap. No, it's brrr, 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 right? He backs, opens his eyes, makes sure he's on target, and closes them. Because if he left his eyes open, they would pop out. That's how hard he is hitting the tree. So he has to close his eyes. He goes, yep, yep, very, very fast. All right, so what does he do? He's got the hole in there, and he goes, ooh, there's some bugs down there. I'm going to get me a bug. He needs a special kind of tongue. You and I cannot put our tongue in a hole and get a slimy bug out of there. Not that we'd want to, mind you, but he wants to. So God designed his tongue in a special way. He gave him this tongue, and he put a little glue factory in his mouth. So he squirts a little glue on there, and he sticks his tongue into the hole, and he catches the bug, brings the bug up, and tries to swallow it, but if God didn't put another little factory in there that dissolves the glue. All right, so as he dissolves this glue. It also has little barbs on it, on the end of his tongue. And one woodpecker, the European green woodpecker, has a tongue. Now get this. This has always amazed me. Ours comes from the base of our throat and comes out our mouth, right? His comes out it comes out his throat. It goes back around his neck, underneath his feathers, up over his skull, down into his nostril, out his beak, and he can get it out there about, I think I put it in, nope. He can get it out there almost 12 some kind of inches, so that he can do that, and then he pulls it right back in. And he's got the glue on there. He's got the barbs on there. God designed him to do exactly what he was supposed to do. All right? How about my friend the giraffe? You ever stood next to a giraffe at the zoo? It's like, whoa, I'm looking at his kneecaps. 20 feet tall, some of them are. So, what's interesting about a giraffe is he's got a heart. Our heart's about this size, the size of your fist. Okay? So it's right there. It's about the size of your fist. His heart is about 5 pounds. Because, think about this, how do you get blood from his heart up to his brain? He has to pump. It has to be a huge pump to pump up against gravity. Now, that poses a little problem, because what happens when he gets a drink? Now he puts his head down below his heart, You got this big old huge pump that's going. He blows his brains out. Except we have giraffes, so what's different? Well, God designed his neck, the veins, the arteries in his neck, that when he bends down, there's little flaps in there that close off that artery. A whole series of them. So as he bends down, they slowly close, which is great. Okay, takes his drink, he's doing fine. Mr. Lion is across the pond, and he goes, oops, I got to get out of here. So he lifts his head up and starts to he takes 3 steps, and he passes out because you got to let the valves open, right? Otherwise, you don't have any blood to your brain. So God said, just a minute, I got this covered. He put a little sponge at the base of his brain. So as he goes down, the sponge fills up with blood. The valves close. He takes his drink. Mr. Lion's waiting for him. He picks his head up. The valves start to open, and the sponge does this. Squeeze. Just enough to get him going until the blood gets up there. Is that a design? Yes, surely is. Anybody ever heard of a cuttlefish? You don't cuddle with them. No. Okay, here's a cuttlefish. I'm going to skip over that one, but okay. The cuttlefish are interesting because they can change colors, shapes, texture on their skin. They even have the ability to turn on the lights. They can swim. They can, they have negative buoyancy, so they can just go. They can go up and down, or zero buoyancy, so they can go up and down what they want to. They can float. They change their color to green as they're floating around in the algae and going, I'm waiting for some food to come by here, and they look like the algae. But they can change colors. If they get mad, they can lay on the bottom, change color to look like the bottom so that they can camouflage themselves. If they get mad, they might turn blue or green or whatever, who knows, okay? The other animal that does this is the octopus or squids. But, yeah, I'm going to skip by the video part. So it's going down, but as it's honing in on its prey, it comes in, and you've seen these lights on theater marquees. Remember the lights that used to look, if it looked like, you watched them close, it looked like they were going like this, right around, and lots of them, they were all in sync. He does the exact same thing. He comes in and turns these lights on, and you're going, the poor crab must be sitting there going, this must be a UFO or something. I don't know what this is, because he kind of gets mesmerized by these lights, and then he gets close, and those little toys at New Year's where you blow on them and they unroll, and then they have a little thing. He's got 2 flaps on the sides of his jaw, and he's got one of those on each side. And he gets close, and when he gets there, he inflates them and goes and grabs them, and then puts them back, and then he eats the crab. All right? So God has designed these little creatures with these marvelous abilities. I have a video of an octopus sitting on a sand bottom, and there's one coral sitting there. Looks like a bush. And the divers just has no clue, and he's swimming and swimming. He's got a camera, and he gets about this close. The octopus goes, hey, I'm here, and takes off. Inks him, goes off. So they turn around, they ran it backwards. And when you run it backwards, he comes in, sits on the outside of the coral, and changes, and you cannot even see it, okay, even though you just watched it. It'd be hard to pick out his edges. He has bumps on his skin. He has the same color, same everything. You wouldn't know that at all. So God designed him to be able to do that. Let me just go by these. There we go. Okay, Colossians 1:16 to 17 says, "For all things were created in him, the things in heaven, the things on the earth, the visible and the invisible. All things were created through him and for him. And by him all things consist." What does consist mean? Held together, right? Ever heard of laminin? It's a little molecule in your body. It's a little protein. It holds things together in your body. You want to see what shape it is? Does it look like a cross to you? Doesn't prove there's God, but boy, that's a great evidence. Let me tell you. All right? By him, all things. This holds everything together in your body. Muscle to bone, muscle to tendon, muscle to subcutaneous tissue. It holds it all together. All right? So, for the invisible things from him, from the creation of the world, are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse. And evolutionists standing before God, professing to be wise, they became fools. And God says, "Depart from me, I didn't even know you." All right? So, Revelation, we need to glorify God. "O Lord, you are worthy to receive glory and honor and power because you created all things, and for your will they are and were created." Because he wanted them to. So remember, Psalm 118, it's better to trust in the Lord than to put your confidence in man. And this verse. Go out and listen to the animals and the plants and the everything and see. They know that God has done this. Now, we'll see if this works. Let's see. Sounds like it's gonna. Nope, it's not gonna. All right. It's just a music video that the Wild Men's Ensemble put together. The whole earth is full of the Lord. And no, that's not it. That's okay. That's all right. I'll open it up for questions. Let me just get through there. It's just a shameless way for me to get all the pictures I've taken, put them in there. So, okay, to trust in the Lord. There we go. Any questions that you have? Where's my guy that's good? Go ahead, ask it. Yes, sir. What is this? Totally unrehearsed question.
Yeah, explain the ice age
Sure.
after the flood, how it happened.
Sure.
Repeat the question.
How did we get an ice age? All right. Secular scientists said there must have been 10 or 12 or sometimes 4, 5, 6. They have no clue. They last thousands of years according to them. The one time that we had the proper conditions for an ice age was right after the flood. And the reason it was the proper conditions is because of several things. One, you had all that water, right? You got all that water from the flood, and it was warm water. What happened? Because the fountains of the deep broke open, filled it up, we got all this hot water. The water temperature of the ocean at that time, they are estimating, may have been upwards close to 80 degrees Fahrenheit. So here's this hot water. Hot water does what? Evaporates, puts a lot of moisture in the air. Not only do we have the moisture in the air, now we got the continents have moved, the plate tectonics. Well, and the fountains of the deep, I believe when the fountains of the deep broke open, the plates moved, and we got the continents as we see them today. We got slight changes in the weather patterns. And so now we got strong winds taking lots of moisture and putting it over northern reaches that are now, the land masses are colder. Okay? Because the temperatures have gone down. we got cloudy skies because of all the volcanoes that are going off. You got a lot of dust and soot and all kinds of things in the atmosphere. So not as much sun is going through, and we get snow coming down. And because we don't have a lot of sun for several years, what happens? Snow keeps building up. All right? Because it doesn't melt during the summer. Like around here. Wintertime, the temperature goes down, the dry land is colder, it snows, it sticks, right? We get to springtime, the sun's up a little longer. Heats up the land, snow goes away, everything starts to grow. So after the flood, you've got huge amounts of water vapor, and you got changing temperatures. The one thing the evolutionists, secular humanists cannot come up with is, how do you get an ice age, all right, without a flood? Because we have snow, but are we under an ice age in Minnesota all year round? No. Are there still praise the Lord, right? We don't have it all year round. But we still have glaciers because, remember, Greenland is not green and Iceland does not have ice. So Greenland is a large glacier. They're there. Mountain passes, those glaciers are still there. They don't completely melt off because they're at higher altitudes usually. So they're colder. And they just build up. Some years they're bigger, some years they're smaller. But the only logical way to get an ice age is after the flood.
Were the glaciers that formed a lot of the land formations part of that time period?
Yeah. The glacier, the ice age, from Noah's flood, went from the North Pole here, let's just take our state, went down to northern parts of Iowa. In fact, we would be under about 2 miles of ice here at the peak of the ice age. That's why the lakes formed. All right? As it melted, what happens? You got huge amounts of ice, presses down on the softer parts, this parts between the rocks, pretty much. All right? That water melts. What does it do? Just stays there. That's why we got fresh water here. We don't have salt water. We have fresh water. Because that wind blew in. You know, when it evaporates from even the sea, the ocean, it doesn't carry the salt with it. So you get fresh water. So we got all our fresh water. Those lakes formed. All right? Now, it went out to, from here, it kind of curved out to the Rocky Mountains and then stopped because those mountains blocked part of that ice from coming down. And it went, let's see if I can remember my map right, across Ohio, along the Great Lakes. Okay, they were buried. Same way across Siberia, northern part of Canada, Alaska. Okay, so you've got all those northern areas covered with ice. And eventually, a meteorologist, I have a book from Michael Ord, he calculated that the ice age probably lasted, let me see if I get this right, if I can remember. It's like 300 years, and it took about 100 years maybe. I might be a little bit off on that, to get rid of it. Just calculating, possibly. Now, is that a long time? Well, yeah, to us, 100 years is a long time, but in the scheme of things on the earth, it's a drop in a hat. Okay? So, that's why we have buried animals. Why do we have, for instance, you have to stop and kind of tie all this together. Why do we have warm-blooded animals like woolly mammoths buried in northern Siberia? Why? Should they be up there? Here's the other question. Do they live in the ice? They have to eat like 500, 200 pounds, 300 pounds of grain a day. Where are you going to find it in ice? Okay, they can't live. They can't function up there. So did they normally live up there? Before the flood, or after the flood, before the Ice Age set in. Now, it's not end of flood, start of Ice Age. There's a gap in there. I don't know how many, I'd have to check and see how many years it is, but okay, so there's this gap. It started to build up, Those animals came off the ark. Are there any people up there? Is there any competition for food? No. They just kind of went, whoa, I'm going to, as they walked up and followed the growth patterns. Then the Ice Age hit. We find hundreds and thousands of these woolly mammoths and rhinoceros, hippopotamus, those kind of things, can't live in the ice, buried up there. How does Nebraska have the most buried woolly mammoths and ancient elephants in it? You see elephants wandering around Nebraska today? I drove through the state, I didn't see one. So, but they have found more bones than any other state. And you stop and think, wait a minute, why Nebraska? That was part of the leading edge. Comes across Alaska. They walked across the Bering Strait, all right? As it started to fill in, the water levels were down. They could walk across. They get down, follow along the coastline of Alaska, get down around, and they could cross across in many places across the Rockies, and then they're out in all these fields of grain. And then they disappeared. They died out. So you have to kind of, and that's how we get dinosaur fossils in the Grand Canyon, the Indians saw. Dinosaurs here and there. They, before the flood, were migrating across there. And when they tried to go back, they couldn't. Why is that? The water levels came up. Bering Strait's now what, several hundred feet deep? They couldn't walk back. When somebody says, well, how did they get in Madagascar, they get all those strange animals? Or in Australia, how did they get all those strange animals? They walked. When they tried to go back, they couldn't. So they lived there. I mean, it makes sense to me, so. Any other?
We can do two things at the same time. We'll continue questions, but we'll take the offering at the same time.
Sure, that's fine.
So if we could get two men to pass the plates.
Any other questions?
Super. James, why don't you grab this side here? Oh, here, we got two guys. We're good. So go ahead and keep asking questions. If
Wait,
you can
let me
do
get
two
the young
things at the
lady
same
behind
time.
you. Ladies before gentlemen.
You had touched on it briefly this morning with the stars being millions of light years away.
Yes.
And the scripture with the God rolling and stretching out the firmament.
Yeah.
And I didn't really get it.
Okay, sure. A physicist, and I just lost his name, just like every other name I forget, but he said that when God created the earth, well, let me back up. You know time is not the same at different points on the earth, right? Einstein's physics tells us this. If you're standing here and we look up and see an airplane, their time is not the same time as our time. It's slightly different, okay? If they're going fast enough, the gap gets a little bigger. So if we put an astronaut up in space and they're going 25,000 miles per hour around the Earth, they go around in a couple of hours, right? Is their time different than our time? Did they age a little different? When they're in there, it seems normal to them. Okay, it's not like their watch suddenly goes faster, but, all right? But it is different. They just went 25,000 miles per hour around the Earth several times in a short period of time. So their time is a little different. Okay, we're talking this, right now. Russell Humphreys, that's who did it, the physicist. He said that when you have a black hole, light goes in and doesn't come out. When you have a white hole, light comes out but doesn't go back in. All right? So, God creates the earth on day one. And he creates space on day two, puts it out there, and he says, okay, take the sheet here, and move them. It's like a curtain on a wire. So let's say we're standing at a shower in your house. You take the curtain and you do this. You close it, right? If we both start at the same time here, and God moves this one out very, very rapidly, speed of light, time is different. They'll get out millions of light years, what looks like millions of light years to us, and the light will still be here. Don't ask me to go any farther into Einstein's theory, but for instance, if you and I traveled at the speed of light, and we took off, and we're on a spaceship, and we go to the nearest star, which is 4 light years away. Takes us 4 years back. Okay? Everybody in this room, children, everybody would be dead. We would be 8 years older. Time changed, yeah. Time moved the same here, but we were going at a very fast rate, and that changed our time perspective. Okay? You have to read more about Einstein's physics to kind of pull all that together. But so what he's saying is the light started here at the earth on day one. And when the stars were there, he swung it out on a curtain, like it says in Scripture. So on day 6, Adam and Eve come out, and God says, I gave you the stars. And they're going, the light is there. Didn't take millions of years to get here. Okay? It was like that.
Can you repeat that one more time, the
Einstein's theory of relativity.
with a time?
Yeah, that's in there. Einstein's theory of relativity. Just look up time dilation and time, yeah. It makes it very difficult. Yes.
2 more questions.
Okay.
Couple parts here.
Okay.
Einstein's theory, focus on the word theory.
Okay.
Right, it's a theory.
Yeah.
It's not proven.
Yes, it is.
I think it's theoretical until it's proven.
Okay.
I used to play hairs and all that stuff.
I know.
A lot of people in Christendom, a lot of churches, they don't think the heavens and the earth were created in 6 days.
I know.
Yeah.
They're wrong.
Now the earth was formless and empty. And I think sometimes we hear things like God, blink of an eye, is 1,000 years in our lifespan. We hear those
That's
things,
in
right?
that's in Peter.
So can you help expand a little bit on that to help, debunk that?
Sure.
Where it's not, it is 6 days because, 6-day literal creation versus millions of years. Because that's an evolutionist religion.
Yeah. Okay. First off, that verse in Peter, what does it say? It says, a day, let's see, a day is like 1,000 years, right? And 1,000 years is like a day. Who's that talking about? God. Right. It's not our time. It's his time. So he sees the beginning from the end. So a single day is like 1,000 years, or 1,000 years is like a day. Okay? They forget the second half of that verse. The other part is, when you try to mix evolution and what Scripture says, you run into all kinds of troubles. So for instance, how did our universe get together? Well, according to them, there was the sun, and there was gas around it, and they were spinning, okay? And I'll touch on this on Wednesday, but, you know, they were spinning, and then you get dust particles, and you get little dust particles kind of cling together, and you get dust bunnies, and you get them, and a little bit, those dust bunnies ram into each other, and they get particles, and those particles get bigger particles, and then all of a sudden you got a planet. All right? Let's stop and think a minute. Those particles are going so fast. First of all, when you have an explosion, the particles just go out, right? You ever seen two of them stop and go, hey, let's go around each other? No, they don't. The gravity, there's gravity, I mean, right now there's gravity between you and me. But if we calculate it, it's little bitty tiny, all right? Because we don't have big masses. The gravity between us and the Earth, that's huge. Huge mass, small mass, and we're close, we're standing right on the edge, right? Okay? So you can't get these particles to come together. Their whole theory falls apart right there. You can't make it that way. And what came first? The Earth or the sun? The Earth. That's in verse 1. The sun didn't come till day 4. Yeah. I mean, just right there, you go, wait, And you can't have millions of years between the days, because how do the plants live for 1,000,000 years with no sun? How do they even pollinate?
Right.
With no bugs?
If they're talking about light as in singular and then light as in plural between night and day.
Yeah.
I'm in agreement with you.
No, I know you are.
But here's the thing that I think sometimes that drives Christendom a little bit different. When you hear millions of light years, I think that's really just a misnomer, because God being all that he is, in man's greatness, Voyager was launched in 1977, and it left our solar system in 2013.
Yep.
Hello, we found the Vega system with 10,000 galaxies, and there's only 800 feet. Thank you, Hubble. I mean,
Yeah.
it's just absolutely astounding at how
Yep.
big and huge God is, and I think we're just peanuts and bits
Yeah.
compared to how awesome. the government is,
Exactly,
right?
exactly.
We can't always explain it, and that's, I think, that part
And-
that's the attraction to it. So,
And I don't think we have to explain everything.
right.
Right.
There's-
Sometimes it just says, God did it. I don't know how he did it. Okay? And the other thing I just want to, when you said that, we are in the perfect position around our sun,
Yeah.
not only from the sun and from the moon and everything that helps us there, but in the galaxy that we're in, we are not in an arm. We are between an arm. And you know what that does? God gave us an arm of the galaxy. Those arms come out, they spin, okay? If we were in an arm, we could not see anything beyond, okay, what was around us. God put us between two arms. Let me do it this way. Two arms, put us right in the middle.
Yeah.
And so we can see everything out this way and everything out this way. We would have no clue if we were inside an arm. So God, in his infinite wisdom, put us in a place where we could see other things. Yeah.
Thank you.
Sure. Yeah, one more.
Jim, could you kind of go through irreducible complexity, how certain things could not have evolved?
Sure.
With modifications over time, like Darwin's thing?
Okay. Irreducible complexity, you see, is, let's say this is a mousetrap. You've all seen mousetraps, right? They have 5 parts. They got the base, right? They've got a latch. They got a spring. They got a little thing to hold the bait on, okay? And they got a little nubbin over here to hold the latch on. So the latch comes over, holds the spring on, put on there, it wiggles that, and it goes, all right? Take one part off of there. Does that mousetrap work? That's irreducible complexity. You cannot reduce it any farther and have it still work. So here's a good example. They always say our eyes are made backwards. You know, he put the rods and the cones in front of I mean, you're going, right. They seem to work. Okay. So, can I take 10% of your eye out and it'll still function? Nope. You got to have it all there to work. It's like anything else. You take out part of your heart, it doesn't work right. right? Take out part of your brain, doesn't work right. That's irreducible complexity. And you see that in everything. For instance, the flagellar motors, yeah, that spin really fast, they look like motors. I mean, they're like jet engines. They spin, they go backwards, and it'll flash, they'll change speeds. They are just amazing. But they're made up of like 9 or 10 proteins that come together from 9 or 10 different places. Take one of those out, that flagella doesn't work.
Yeah, I was, and Darwin said if it could be shown that any complex organ could have come about without successive numerous changes over time, my whole theory would break down,
Exactly.
so.
Yep. And he also said, if we don't find any transitional forms, we should throw this theory out too. Okay, it's been 150 years, we haven't found one. They're not there. So, yeah, that's a good question. But irreducible complexity, just, you can't take something out of it. And a lot of things are like that, a lot of things. So, I just use this, you know, if you take the battery out of this, it doesn't work. So, yeah.
What you're going to be doing on Wednesday?
Wednesday, we're going to look at solar system, our sun, some of the stars, some of the galaxies, some of the things. I remember a quote from Abraham Lincoln says, I can see how a man could look down on earth and not believe in God, but I can't see if he's standing on the earth, he looks up at the sky and can't see God's hand. It's amazing. And when you think of how vast space is and how much is out, and we haven't even seen 80% of it, all right? The vastness of space. And God says, I know the name of every star. Yep. And when you start counting them, yeah. So we're going to look at that, pictures and those kind of things, and then we're going to, I threw in some telescopes and some other things. So.
Why don't you close in prayer?
Sure, I'll close in prayer. Father, we thank you. We thank you for the creation that you've given us. We thank you for the evidence that you've provided that we can look and say, God, you are wonderful. You have created and you have designed these to do exactly what you wanted them to do, to live where they need to live, and to function the way you want them to function. We thank you for that. We thank you for the good questions this evening. We thank you for all these kind people that have come out this evening, and we thank you for all that you've done for us. We especially thank you for our salvation. We praise you and ask that you watch over us, give us safety as we travel home this evening. But Lord, we thank you in Jesus' name. Amen. Thank you.